All right, here are solutions for quiz 5 for Math 211. Kind of a weird quiz, but okay. You're given these symbols, and you can kind of think about these symbols as representing different numbers. And based on which symbols are used where and with which operations, we can decide which of these properties is depicted with each of these, I don't know, jumbles of symbols. So let's go through it. In this case, I have spider plus web equals web. In other words, there's some element out there, spider, that when I add it to some other element web, it does not change that other element web. So what is going on here? Well, spider must be 0, right? 0 plus 7 equals 7, for example. So what's going on is there's this special element with addition that does not change the value of anything that it's added with. And that's what's called the identity element of addition. So here we go. F, the identity property for addition, would go here. This next one, the important thing to note here is that scissors, book, and pencil don't change order. Scissors, book, pencil. Scissors, book, pencil. But what does change is the way they're grouped, what I'm associating things with. So this is the associative property, and because there's addition going on there, it's the associative property of addition, aka A. This one is, well, I don't know, I guess one way you could process of elimination things is know that you have multiplication and addition. So I have something, I don't know, a movie ticket maybe, times whatever those things are called, plus a camera. And then I'm changing that into movie ticket times whatever those things are called, plus the movie ticket times the camera. Really what's going on here is the distributive property, more specifically the distributive property of multiplication over addition, which is right here, yeah? Yeah, E. This one says that when you add together dinner and a drink, you get the same thing as when you add together a drink and dinner. In other words, the order that you add things doesn't matter. That's the commutative property. And in this case, since there's a bunch of addition going on, it's the commutative property of addition, C. This one is exceedingly difficult. I think this is the hardest one on here. Because you see the parentheses and you're like, easy, associative. Except this time there's multiplication, so it must be associative of multiplication. It's kind of tricky like that because the associative property says that the order things are listed must stay the same. You just group them differently. Note here the order is changing. I got a snowboarder guy here times golf times swimming. And then I got golf times swimming times the snowboarder guy. Really what's changing is in this one I'm taking snowboarder times something else. And in this one I'm taking something else times the snowboarder. The order that I multiply together two things doesn't make a difference. This is actually the commutative property of multiplication. That's a hard one. Down here, 6 is a lot like 3. Nope, 6 is a lot like 2 in that I associate things differently, but the order that I draw these little animals is the same with a little chipmunk and a, I don't know, dog and a cat. Chipmunk, dog, cat. Maybe that's not a dog. Maybe that's a horse. Whatever the hell it is. The point is they're in the same order. I'm just grouping them differently. That's the associative property. And since it's all multiplication in this one, it would be the associative property of multiplication, which is B. And then this one, pretty straightforward. It's a lot like 4 in that plane times bus is the same as bus times plane. That's commutative. But since it's multiplication, it's the commutative property of multiplication, which is a D. Equation 8 uses three of the above properties. Explain which 3 it is using. Okay, I don't want to draw a whole bunch of rain clouds, nor do I want to draw a whole bunch of suns plus cloudy days. So really what I'm going to do is say I have R times S plus C is equal to, well, I guess that's C in my notation, times R plus S times R. And you're like, that just looks like distributive, where you're changing multiplication and addition into the sum of two different terms, each that have multiplication in them. Yes and no. What the distributive property lets me do is change R times S plus C into R times S plus R times C. And that's not quite what I have here, right? That's close. The first thing that I'm doing is using the distributive property of multiplication over addition. So that would be E. And maybe I'll even write here distributive. And then what I'm doing is, well, over here I have C and R as my first term and S and R in my second term. Over here, the S and R are in my first term and the C and R are my second term. I want to switch those up a little bit. So I want to change the order that I'm adding things. Instead of taking this and adding this, I want to take this and add this. So I'm going to take this R times C and add to that R times S. And so this is commutative property, specifically commutative of addition. And the commutative property of addition, here we go, C. And this still isn't this, right? It's pretty close, but the orders are switched around. Instead of C times R, it's R times C. Instead of S times R, it's R times S. So to switch that around, if I wanted to change the order that I'm multiplying things, I would again be using the commutative property, but now it's the commutative of multiplication, which is D here. So the three you're using, E, C, and D, I'm going to call this my explanation over here. And I didn't really give you a lot of room to explain. But I don't know, you'll figure it out. Equation 9 here can be thought of depicting one of two properties above. That's pretty tricky. I got lock times key equals lock, which I did not see up here, I don't believe. So a couple ways you can think about this. You can say that there is some special element out there, key, and when you multiply it by anything else, lock or something else, it leaves that lock alone. So you could think that that I have this identity element of multiplication, identity property for multiplication, there it is, G. So G, and my logic for this being G is if the key is 1. Right, then 1 times some number like 9 equals 9. Sure, that'll work. But you can also think about it differently. You can think about the lock as 0. So if the lock is 0, then what I'm saying is 0 times any other number, I don't know, 13 equals 0. Lock times anything else still equals lock. So if the lock is 0, I have the 0 property, which is not on my list. That's a bummer. I'm going to have to go add that after the fact. E, F, G, H, I. This is the 0. Oh, here it is. Multiplicate. I saw it. Never mind. H. Multiplicative property of 0. It is already on my list. That's nice. That's less editing for me to have to do. If the lock is a 0, you get an H. So two different possibilities depending on how you interpret stuff. G and H would be the answer. And that right there ends this quiz.